All right, so that's 152, number 7. So let's take a look. A bus service carries 10,000 people daily between Ajax and Union Station, and the company has the space to serve up to 15,000 people per day. So right off the bat, I'm seeing that we've got an upper limit here, that if I get an answer which produces more than 15,000 people, that would not be part of my domain. So the cost to ride a bus is $20. Every time we increase by 50 cents, 200 fewer people ride the bus. What fare should be charged to get the maximum revenue, given that the bus company must have at least $130,000 in fare to cover the operating costs? Okay, so again here, we've got a bunch of things that are given. Let's see if we can figure out how to solve this problem. Now, as we know, with these types of problems, there's two ways to approach it, okay? You can solve the problem where X is the number of riders, or the number of items or units, okay? Or you can solve the problem where X is the number of price increases or decreases, okay? So what I'll do is I'm going to solve it by saying, let X be the number of riders. Okay, now, unfortunately, because I'm using meat, I'm stuck. My screen is taken up by the question and my solution. So if you have a question here, I'm going to need you to say it out loud, okay? So I won't be able to see it. The chats may come up, but sometimes I might miss them. Okay, actually, maybe I can fix that by doing that. Okay, actually, I will be able to see the chats. All right. So here, what I want to do is I want to determine the revenue, okay? And we know that the revenue is going to be the number of units, or in this case here, tickets sold to riders, times the price function, okay? So this is the thing that I'm trying to maximize, and we have to find the price function. And based on what it's given, the way things are given is it looks like this is a linear function. So if I'm looking for P here, so we have our 2 points. We have that when there's 10,000 people, okay, the price is 20 bucks. There we go. And then if I lower the price, or sorry, if I increase the price by 50 cents, so 20.50, we have how much? We have 200 fewer people. Okay, so we've got 9,800 not using the bus. Okay, so my slope is just going to be, well, this is going to be y2 minus y1. Okay, so that's going to be 0.5. Okay, divided by 980 minus 10,000, so negative 200, so minus 0.5 over 200. Okay, so now the price function, let's just stick in one of these here. So we've got 20 equals negative 0.5 over 200 times the X value, 10,000, okay, plus B. And so B is just going to be equal to, and you see that I don't even make an effort to simplify any of this, because I'm going to put this all in my calculator anyway. So I might as well just do it that way. Okay, so here I've got 20. I'm bringing this to the other side, so it's going to be plus, okay, and it's 0.5 times 10,000 divided by 200 equals 45. Okay, so now that means we have our revenue function, okay, which is going to be equal to, remember we have X times, and what's our price function? Well, our price function here, actually probably a good idea to simplify that. So 0.5 divided by 200 is equal to 0.0025. So we've got negative 0.0025x plus 45. Okay. And so now this is the function that I'm trying to maximize. Okay. Now let's try to figure out what the domain is on this one here. Okay. Now, let's try to figure out what the starting and ending point is. So what are the restrictions they give us on this function here? Can anybody tell me what the restrictions are?
It has to be like you can have at least 0 people
Okay.
and less than 15,000.
Okay, and less than 15,000 people. So you definitely need X. I'll just write it here on the bottom. So X has to be less than or equal to 15,000 people. Now, X definitely has to be greater than 0. But technically, there's another restriction given here. What's the other restriction?
Well, if 200 people leave every time that you increase the price, then actually, no, never mind.
Yeah, that's a good point. But the other restriction that I'm looking at is that I
they
have to
must
have at
have,
least, yeah,
they
I
must
have
have at least that much.
that much in fares. So the question is do you bother calculating what the X value is that gives you $130,000 in fares? Okay. Well, this is where I'm going to give you a bit of a tip here, is that this is a very easy function to differentiate. Okay. And of course, once we get our critical point, can somebody tell me why I know it's guaranteed to be a local minimum? Sorry, yeah, a local maximum. Why is it guaranteed to be a local maximum?
Because the cost isn't like variable. It's just it doesn't change.
Yeah. But there you go, because it's a quadratic function with a negative leading coefficient. So I would say that since this is such an easy function to deal with, I'm not going to bother taking the time worrying about the other side of this inequality. As long as in the end, my revenue ends up being over 130,000, then I know I've got no problem, okay? If it doesn't, then I may have to work backwards and see what happens. All right, so let's take a look here. We've got our revenue, take the derivative. Okay, so I'll assume that I've put this out. So this is just going to be x squared. So it's going to be 2 times negative 0.0025 x, okay, plus derivative of 45x is just going to be 45. And I want to make that equal to 0. And so what do we have? We just have x is equal to this negative, when I divide, is going to make everything positive because it's going to be negative 45. Okay, I'll just write it out. It's going to be negative 45 over negative 2 times 0.0025. All right. And let's see what we get with our critical point. So what do we have? We know the negatives are going to cancel out. So 45 divided by 2 times 0.0025. Okay. And that gives us, oh, I must have put something wrong there. Let's try again. 45 divided by 2 times 0.0025. And there you go. We got 9,000. Okay. Okay. Which I know is going to be, okay, because it's a quadratic with a negative leading coefficient, I know that this gives me an absolute max since it's quadratic and a is less than 0. Okay, so this tells me how many people I get, but what should I be checking to make sure that I've actually solved this problem? What's that extra condition we said we had to consider here? Is we had to consider the fact that the revenue needed to be at least 130,000. So I better check that that's going to be the case before I go ahead and give my answer here. So negative 0.0025 times 9,000, okay, plus 45, okay, and then times 9,000, And there you go. So there's no problem with meeting the minimum number of the minimum revenue. Okay. But when I go back to my question, it asks what fare should we charge? So what am I going to do now that I have the number of riders? I can now, so here I'll just put here that revenue is greater than 130,000. So we're good. Okay. So the last thing I have to do is take this 9,000 and put it into my price function. Okay. So the price that I'm going to charge is I'm going to find that at 9,000. So it's negative 0.0025 times 9,000 plus 45. Okay. And let's see what we get here. Okay. Negative 0.0025 times 9,000 plus 45. And it looks like we're going to charge $22.50. Okay, and there we go. Okay, so I saw that the person that had asked had just made a little error in terms of the finding the intercepts. Does anybody have any other questions on this one here? Okay, so who can tell me why I don't have to test the endpoints? I sort of referenced it here.
Because it's a parabola, and you know that that's max.
Yeah, so you see here, unfortunately, my screen's got gone a little dead here, but you can sort of see it right on the left. I didn't really need to check that just because it happened to be a parabola with a negative leading coefficient. So I know that the value at the critical point has to be an absolute maximum in this case. Is that okay, Kiara? Yeah, perfect. Okay, so my camera seems to have died, so I'm just going to try restarting that here. And hopefully it starts working again. There we go. Oh, let's hope. I'm going to try that one more time. Otherwise, I luckily have another program that'll work. Okay, looks like we're back on. Okay, so if is there anything else on this question? If not, do we have something else do we want to take a look at? Or Ali, if you had found maybe one of those questions where you had a tough time finding the domain. I guess in principle, marginal revenue could be on the test, but essentially what do we have to remember about that word marginal? What does that word marginal mean calculus-wise? Can anybody tell me what we mean by marginal revenue?
It's just a derivative.
There you go. That calculus-wise, it just represents the derivative of the revenue function. And the idea is what the derivative is representing is at that moment in time, if I sell one more product, how much more money am I going to make? So it's just the slope of the tangent to that curve. So it's just the derivative. So if you do see the word marginal revenue, the words marginal revenue, you just know it means, you know, the derivative of the revenue function. Okay? That's about as much as you need to know at this point with respect to marginal revenue. Okay, good question. Anything else we want to ask with regards to the test tomorrow? Even more general things.
Are you going to indicate which questions are from lesson 1 to 4 and which ones are 5 and 6?
Yeah, essentially what I can even tell you, I've decided how I'm structuring that. So there will be one question, okay, in the it's sort of going to be in the thinking realm. It's going to be a fairly short test, so I may not split it up into those categories as usual, but there's going to be one question where you're either going to have the choice to solve an optimization question or to solve a question that includes one implicit differentiation and one related rates. So that's going to be your choice. You can choose to solve either one of those scenarios, either the extra optimization question or the two questions. One's going to be a related rates, one's going to be a implicit differentiation. So you can take a look at the questions and see which one you want to do. Okay. So anyone who's here, again, by and large, I would say, the questions are going to be from the set of questions that we've done. Certainly, probably likely to take, for the most part, maybe with one exception, questions that are, have been done at least a couple of times in the homework or the assignment. Okay. But again, keep in mind that if you've kind of only joined us this week, or even if you were working on this stuff last week and you kind of feel, you know what, I'm just gonna, I'd rather focus my time on optimization and not worry so much about the other two sections, you have the option not to solve implicit differentiation or related rates.
And can we like do implicit differentiation and not related rates or something like that as well?
The problem with that is that it starts to mean I have to make the test a little long. Okay, so that was the original plan, but I don't think, I just don't want to make the test too long. Okay, so I think we'll just leave it as it is there, where you kind of have the combo, or you can do the what do you call that? Extra optimization question. Okay. Yep. Anything else?
Are there going to be like the trigonometric like optimization? Like there was one in the textbook, I think.
I would say, if I were betting on it, given how little time I have to test you and we spend so little time on it, I'd probably say, it would be a less likely thing to expect. Is that vague enough?
Yeah.
But in a precise sort of way. So the length of the test, so it looks like, I think it's going to be 60 minutes plus 15 minutes to scan and send me your documents. I'm going to take another look. I'm sort of staying away from the tests for a bit, and then I'm going to look back at them later today. And if I feel like I want to add an extra 5 or 10 minutes. So when you get the email, you will say, this is how much time you have in total. Again, I hope everybody has practiced using a one of those scanners, okay, that you've scanned something with more than one page, you've turned it into a single PDF document, and you've sent it to yourself by email, so you know exactly what to do tomorrow. I will be by the computer the whole time, so if you have any issues, you just email me. But again, other than looking at the test or emailing me, that's the only thing obviously you should be accessing the computer or anything else for.
For the actual like test, you recommend us like printing it out, or do we just like write down number one?
I actually think that's the best thing. So first of all, not everybody has a printer, and you got to take time. And what if the printer jams and the whole thing? I would just say, do the questions on a separate sheet of paper. Having said that, if you're someone who really likes having being constricted to a certain amount of space, then you can print it out. So I'll accept either, but I'd almost suggest maybe, especially since some of these questions, they are multi-step, and some people write a little bigger. So I would say, perfectly fine to just write on a separate sheet of paper.
Okay, thank you.
Oh, I should add to that, as legibly as possible, and I wish I could remember who uses the very light pencils. If you're a light pencil person, I need you to please not use a light pencil, because it's going to be very difficult to read on a scanned document. Okay?
If we use like a scrap paper, do we need to send that in too?
If you want me to send me anything you want me to look at as part of your solution. So if you are if there's, say, something, you did something on scrap paper and you say, oh, you know what, I don't want to rewrite all of this because it's actually longer than I thought it was going to be, then you might as well just scan that page and just say this is for number 2 or something like that. Okay, I would say don't, if you have something that you wrote on what you thought was scrap paper but came out kind of nice and has everything you need, then don't bother rewriting it unless you really need to or want to. Okay.
Okay, thank you.
Does it matter if the questions are slightly out of order as long as they are labeled? Yeah, I mean, look, obviously it's nicer if they're in order, but no. I'd rather you, if you're not printing out the test, I would rather just do whatever's going to not waste your time. So just make sure everything is clearly labeled. I think now that you're mentioning that, I think what I will do is, if I do break it up, if it ends up being in sections, I'll just go from like 1 to 7. I won't kind of do application 1 and thinking 1, just so that it's very clear that you just give me the question number. Okay, good question. Who was it that was asking? Somebody was asking about subtractions when you're subtracting vectors. So if you haven't gotten to the vectors portion here, I mean, maybe you don't want to be looking at this yet. Don't want anything to confuse you, but two things to remember, okay? That there's two ways of looking at addition and subtraction. One of them is through placing the vectors tip to tail, and the other one is placing the vectors tail to tail, okay? So if you're adding two vectors, say I have vector u, and I'm adding a vector to it. If I use the tip to tail method, well, I'm going to take the second vector, put it to the tip of u, and then what gives me the sum, okay, and the rule is from the tail of the first vector to the tip of the second vector. So that's going to be u plus v, okay? So that now, if I want to subtract u and v, I can still use this tip to tail method, but think as u minus v, and think of it as u plus negative v, okay? And then what's the only difference between v and negative b? Well, it's just the opposite direction. So what would that look like? So here's my vector u. And what I would be doing now, if I'm using this method of doing subtraction, is I would be adding negative v. So it would just be v, but going in the other direction. There you go. So I'm adding negative v, and I follow the same rule as I always do for addition, from the tail of the first vector to the tip of the second. So that would be u minus v. Okay? So is that okay in terms of what I did?
Yeah, that makes sense.
Okay. Now, there is an alternate way of looking at vector addition and subtraction. And as we saw, if you were at the lesson, you saw that, hey, wait a minute, sometimes they give us the information as the angle between the vectors. So in that case there, if I'm working with the vectors tail to tail, then the way in which I describe addition and subtraction looks a little different. That addition, okay, is you create a parallelogram with your two vectors, and it's the diagonal that goes from the two tails to the other end of the parallelogram. But you can see very easily that it's equivalent to what we did before, because if you look at it this way, u plus v, if I put them tip to tail, gives me the exact same answer, because here to there, and what's u plus v? From the tip of the tail of the first to the tip of the second. Okay, so very easy to see that it's identical. Okay. For subtraction, it's maybe not quite as obvious, but if I want to do u minus v, okay, u minus v, okay, the way we describe that, when they're tail to tail, is from the tip of the second to the tip of the first. Okay, so if I want to do u minus v, I'm going to go from the tip of the second, which is v, to the tip of the first, and that represents the subtraction. Whereas if I want to do v minus u, well, it would be a very similar looking vector, except now the second vector is u, so it would be from the tip of v to the tip of u to the tip of v. So this is v minus u, and the red one is u minus v. Okay, so it's the other diagonal, but as expected, they're opposite vectors. Okay, so when you're subtracting two vectors and they're tail to tail, it's from the tip of the second to the tip of the first. Okay, when you're adding things using tip to tail method, the resultant is from the tail of the first to the tip of the second. Okay, does that
Yeah, I understand now. Thank you.
perfect, excellent.